sys.dmdb index physical stats, it described to me the shape of my index, but it didn't give me exact page numbers. I can get page numbers from an undocumented dynamic management view that we got in SQL Server 2012 called sys.dmdb database page allocations. Similarly, I'm telling SQL Server, I want to look in this database at the dim employee table for index ID 28, and I want detailed information from that. This will look at all of the pages assigned to that object and return to me, okay, what are the page numbers? I'm going to take those page numbers and plug them into more undocumented commands to say, hey, what's on this page? Let's take a look at it. I only want to look at index pages, and I only want pages that have been allocated. Right now, for my index, there's only one page at page level 2. That's our root page of the index, and here is its page number. Page level 1, that is our intermediate pages of the index. That level that only has 2 pages in it. And we get the page numbers for that. And for that level, we also have more information. Because there's more than one page in the level, we can see that the first page at the intermediate level, it knows who the next page is, and the next page knows who the previous page are. These pages, when there's more than one page at a level, they have pointers back and forth. Here, page level 0, these are our leaf level pages for the index. And those, here's the first leaf page. It says, okay, I know who the next page in line is, and then so on and so forth. We're going to start here at the root, and I'm copying out the page ID for the root of our index, and I'm going to paste that into this command right here. But before I run it, before I run the undocumented dbcc page command, I'm going to make sure that I have a trace flag on for my session. dbcc trace on 3604 says, please take the output from dbcc page if I run it and put it in my messages tab here in Management Studio. Please return it to me. So I've turned on that trace flag, and now I can run the undocumented dbcc page. I give it the name of a database, the file number I want to look at pages in, the page number I want to look at, and then information about the style of results I want to get. My previous query did tell me against the sys.dmdb database page allocations, it did tell me if I look here in allocated page file ID, all of these pages are in database file 1 for this database. I haven't configured this with multiple data files. So data file 1, here is our page number that we copied out for the root, and I want to look at this index page. This is a non-clustered index, and I want this result style 3, which will return information for what's on this page in this nice, convenient table format. It says this page is in file ID 1, and then here's the page number that we're looking at. There are 2 rows on this page. I am at currently index level 2. That's where my root page is. These child pages, they are each also in file ID 1, and here are the page IDs of the child pages. And then I get some interesting information in 3 columns. Notice that I have 3 key columns here. I defined my index with 3 key columns, and they are all on the root page. And they have, for the first child page, they just say null. And then for the second child page, they have some sample data. These are guideposts. These data for the key columns, these data columns, are guiding me if I'm looking for data. Let's say I'm looking for the last name Adams. Well, the guidepost I have for the second page is telling me this child page manages data for this value and higher. If I want a value lower or previous to that, such as Adams, I want to look on the child page before that, which in this case, it's the first one. It doesn't have a guidepost. It's everything up to, but just before the guidepost for the next page. Well, that's interesting. Let's take a look at these child pages. I'm going to copy that first child page there, and now I'm going to copy the second child page, and we're going to plug those into more dbcc page commands. We're now looking at the intermediate pages. Looking at the first intermediate page, it has quite a few rows. It has 186 child pages that it knows about. On this intermediate page, we have those key columns listed again with more of these guideposts. We don't have any of those included columns here though. Neither the root page nor this intermediate page had anything about those included columns. We simply have sample values for the key columns. And so we can see for the first row, we again have nulls because it contains everything up to, everything just before the last name Abra's first name Luca, and so on. So we have these guideposts saying if we are looking for a row, here's where to go to find it. We can also see a really clear information on how this is all sorted. Everything is sorted first by last name. The sorting for first name only comes in if we have a duplicate value for last name. We have two Alexanders, so David comes first and then Michelle. But if we were to just look at first name without looking at last name, these can be in any order, right? Because we have a variety of last names. We don't have a lot of duplicates in that. So the sorting of the second column only comes into play when we have a duplicate value for the first name. Similarly, for employee key, we would only have to explicitly, change an order for that if we had duplicate values for a last name and then also for first name. In that case, the third key would determine what order they were in. So that first key column, this first key column of last name is incredibly powerful in terms of placing rows in this index, because in this case, we have a lot of unique values for that last name column. Let's look at our other intermediate page. We have two intermediate pages. This first one knew about a lot of child pages. Looking at our second intermediate page with this dbcc page command, it has fewer child pages it knows about. It only knows about 58. So this isn't, evenly, there's no balance that has to be maintained if they don't have to evenly divide the children that they know about. And our first line here, our first guidepost on this page is to a familiar value. This was the guidepost to this page on our root page. Surya Stajatterskool, apologies Surya for mangling your name, she has data on this child page 158449. Let's take a look at that child page. I'm going to plug that into this command, which we know our index has 3 levels. We've already looked at 2 levels, so this should be the leaf of the index. This should be the final level. And sure enough, when I look at this page, there's only 1 row on this page. That's because I did that dastardly trick when I created the index and I said with fill factor 1, fill factor applies to the leaf of the index. It was only able to put 1 row on this page, and it is for Surya. And notice, we are at the leaf of the index. There's no child page for the leaf. We are at the lowest level of the index, or of our tree. We're at the leaf level. There's nothing further. And we have more than just our key columns. We have the 3 columns and they're sorted, but then we also have the columns I defined as the included columns. We have middle name, the emergency contact, as well as the status. The leaf level of the index contains the keys, and things are ordered by the keys. Then whatever we defined as those included columns are also present here. So that if I want to run a query that says, okay, please give me the status of the employee with this last name and this first name and this employee key, it can get me that status information without having to go look at any other structure. It doesn't have to go check for anything in the base table. It is included in the leaf of my index.